the homogeneous recurrence relation, a sub n is equal to 3 times a sub n minus 1 minus 2 a sub n minus 2, with initial condition a0 is 1 and a sub 1 is 3. So we'll turn this into a characteristic equation. A sub n will be r squared, a sub n minus 1 is r, and then a sub n minus 2 is just 1. And then just bring it all to one side. Factor this out. This will be r minus 2 times r minus 1 equals 0. And so we get 1 and 2 as our roots. So we know that the general form is going to be some constant times and then 1 to the nth power plus some constant times 2 to some power. Now we want to use the initial condition, so we have, starting off with n equals 0, we have c1 times 1 to the 0 power plus c2 times 2 to the 0 power. And so this will be c1 plus c2, which is equal to 1. And then for a sub 1, we have c1 times 1 to the first power plus c2 times 2 to the first power. This is c1 plus 2c2, which is equal to 3. This is a system of equations, so I'm just going to subtract c1 plus c2 equals 1 with c1 plus 2c2 equals 3. The c1s are going to cancel. c2 minus 2c2 is negative c2. 1 minus 3 is negative 2. Divide both sides by negative 1. We have c2 is equal to 2. And then if c2 is 2, we can just plug it in over here. We have c1 plus 2 equals 1, which means c1 is negative 1. And so now we have enough to go back to the general form. So over here, a sub n, we're going to replace c1 with negative 1. And here we have 1 to the nth power, which that's always going to be 1, so I'm not even going to bother writing it. And then plus 2, and then times 2 to the n, which I can rewrite this as negative 1 plus 2 to the n plus 1. So this is the final answer.